Okay, let's focus. For this question right here, what do you do first? Okay, can you switch it? I'm so glad you said that. What would we switch? The denominator? And do what? What? Bring it up. I could bring the denominator up. Now, be careful. The most common mistake people have told me today is switch them by bringing the denominator up and this 4ab to the bottom. Bless you. Why is that wrong? The b is the only one that has the negative 1/2. Are there parentheses around this 4ab? No. So you cannot switch these two. On top of that, there is a minus sign, bless you, right here. Can I change this b to the negative 1/2 to the bottom if there's a minus sign right here? No, you would only move it to this one right here, and we're not going to do that. So I'm actually going to show you two different ways to approach this. The first way is going to be what Lynn said, and I'm going to switch it to the top. So I'm going to bring it out front, a squared b to the 1/2, multiplied by, and then I'm just going to leave the numerator how it is. Do y'all agree with what I just did there? I got rid of the negative by moving it to the top. Now what? Oh, and I forgot my equal signs. Don't forget your equal signs tomorrow. Before you turn in that quiz, make sure you have equal signs. What'd you say? Distribute. I'm going to distribute this 1/2 to both of these. So that's going to give me a to the 1, or just a, and b to the 1/2. Is that what you meant, or did you mean the other way? We're going to do both. I'm doing it in one second. Yeah. Yeah. And then now what do I need to do? Same word, different concept. I'm distributing it out here. So I'm going to get ab to the 1/2 times 4ab to the negative 1/2 minus ab to the 1/2 times 2ab to the 1/2. Does this make sense? And now what do I do? What coefficient goes out front right here? 4. And then what is a times a? Huh? What's a times a? A squared. And what is b to the 1/2 times b to the 1/2? Negative 1/2. What do we do to those exponents? Add them. What's 1/2 plus negative 1/2? 0. They cancel out. That makes sense? What are you confused about? What I did? No, right here I just distributed. Now I'm just multiplying these. So I'm multiplying this one right here. And when you multiply, remember you add the exponents. So that's how I got. And then I added those and I got 0, so they cancel. Now I'm going to do the same thing right here. So I have a coefficient of 2. What is a times a? A squared. And what's b to the 1/2 times b to the 1/2? 1. So I'm just going to put b. And that is my answer. How do I know to stop right here? There's no like terms, and all there has is a minus, so I can't do anything. I can't combine like terms. This is one way to do this problem. Do I have any questions about any step I took? Yes.
Third line.
Yes.
Where that minus AB comes from?
Right here?
Yeah.
It's this same thing. I had to distribute it to this one. That's where it was right here. And I had to distribute it to that one right there. Does that make sense? So you had to do it to both of them, multiply it times this, and multiply it times this one right here. Just like if you were to have like if I would have had 2x times, or x plus y, I would distribute this right here, and I would get 2x squared, and then I'd distribute it right there, and then 2xy. Does that make sense? Yeah. So that's it's like a term out front. I'm multiplying by both of them. Yep, good question. What else? Okay, I want to address another way to do this. This probably isn't your natural way, like what your instinct would do, but I do want to talk about it. I taught you another way to approach if you have a plus or minus in the numerator. What did we talk about doing? Split it. I could split this and do 4ab to the negative 1/2 over a squared b to the negative 1/2 minus 2a. You don't need to write this down unless you want to, but I just want to show you another way to approach this. I'm going to distribute this exponent at the bottom, so I'm going to leave this. What'd I do wrong here? Oh, that's negative 1 right there. Sorry. Negative 1/2 times 2 is negative 1. I don't know what I was doing there. And then I get negative 1 again. B to the negative 1/2. Do y'all agree with that step I did there? And then now we're just dividing exponents. This has 4 here. A divided by negative a. There's 1 right here. What is 1 minus negative 1? 1 minus negative 1. 2. So that's where you get a squared. And do you agree? B to the negative 1/2 divided by b to the negative 1/2. Those cancel. Right here, I'm left with minus and 2. Again, a to the 1 minus negative 1 is a to the 2. And what is 1/2 minus negative 1/2? 1/2 minus negative 1/2 is 1. And we get the same answer either way. So I just wanted to show you there are different ways to approach this. As long as it mathematically makes sense, you could do this your way. Are there any other questions you have on worksheet 1 that I can answer before moving on to today's lesson? No other questions? Okay, if you can get out the half sheet I gave you that looks like this. If I can remember, we're going to glue this into our notebook. But everybody, we're doing the half sheet. Yes. No, you're good. What's up? Number 42 on. That was 42 on worksheet 1. The one we just did. Yes. Yeah. No, you're good. Right? Is it the same problem? Just double check. That's the one you're asking about. Okay. Yep. Okay. All right. You are getting this paper out. Today we're going to be talking about the graphs of exponential functions, and we are going to graph them. So, if you can get out your pencil and 3 colored pencils. Hopefully you grabbed 3 different colors. So the function equation is f of x equals a to the x. It has that written down. And a can never be 1, and it'll always be bigger than 0. Now, some properties. If a is bigger than 1, underline that right there. If A is bigger than 1, what does that tell us about this graph? Louder? If A is bigger than 1, what does that tell us about the graph? It's exponential. It's increasing, which means it is exponential growth. Exponential growth. What this picture doesn't have that I want you to add in is an asymptote. Tomorrow on your quiz, you will have to graph one of these pictures. And please make sure you include the horizontal asymptote. And if there's no shift, it's the parent function, it's at y equals 0. Now, for all exponential functions, the domain is all real numbers. It is. For the domain is all real numbers. The range is 0 to infinity because of the asymptote, it's above it. Why is the y-intercept at 0, 1? My y-intercept will always be at 0, 1 if there's no shift. Why? Anything to the power of 0 is always 1. All right? Your limit, your end behavior, as x goes to the left, negative infinity, what's happening to my y value? It's getting closer and closer to 0. And put a little positive sign right there. It's getting closer from 0 from the top, from the positive numbers. And as x approaches infinity, meaning as it's going to the right, what's happening to y? It's going up to infinity. Horizontal asymptote at y equals 0. It's increasing. It's 1 to 1. That means it passes both the vertical and the horizontal line test. And it's continuous. How can it be continuous if it has an asymptote? Say it louder. It's always going. It never touches it. And do you have to pick up your pencil to graph this? No, so it's continuous. Okay? Do I have any questions about exponential growth, the graph? All right, flip your paper over. What's different about this function? It's exponential decay because your A would be between 0 and 1. So this is going to cause your graph to decrease, or it is decreasing, and it is exponential decay. The domain is still all real numbers. The range is still, even though it's decay, it's still above my x-axis, so please still draw the horizontal asymptote. What's different now is my end behavior. This time, as x approaches negative infinity to the left, what's happening to my y's? It's going up to infinity. And as x approaches infinity to the right, what's happening to the y here? It's going to 0. Again, with this 0, can y'all put a plus from the top? We talked about the horizontal asymptote. It is decreasing 1 to 1 and still continuous. So again, it just reflects over the y-axis. You need to pay attention to the numbers though. Okay? Again, we're going to glue this in a little bit. If you have written those things down, if you can put this to the side and get out your graph paper, we are going to fold this like a book. Like this. And we're going to do, we're actually going to end up doing 6 problems on here, but we're going to do 2 graphs. The first graph is going to be y equals 3 to the x. And what I would like you to do is I would like you to draw an x and y axis. Go over half the paper, not quite the whole thing, but you can go a little bit over half. You are doing this with your pencil, please. What do you notice? What do you know about this graph right away? It's growth. Why is it growth? It's greater than 1. A is greater than 1. So how do I graph this? My advice is to make a table. So right over here in the little corner, I'm going to make a table. And I'm going to start at let's start with the easiest answer. What is 0? What is 3 to the 0 power? 1. What's 3 to the first power? And 3 to the second? Or 3 squared? 9. Don't put 6. It's 9. What? What about 3 to the negative 1? 1/3. 3 to the negative 2. 1/9. And plot those points. -2, 1/9. Please make sure your graph has arrows. And this right here, you will get points off for on your quiz tomorrow if you graph like this. You need the asymptote. So please make sure whatever you do, whether it's a bold line or you just go past whatever asymptote I give you, please make sure you draw an asymptote on the x-axis. Or wherever it's supposed to be. And you will have one of these on your quiz tomorrow. All right. I would like you to get a colored pencil. And down below, I am going to now do example A. Y equals 3 to the x plus 2. What transformation is going to happen here? What? No, what'd you say? I didn't hear you. Oh, up 2. I'm going to shift up 2. Oh, I forgot to ask y'all. Sorry. What is the domain here? All real numbers. What is my range here? What's the range? What's the y's? 0 to infinity. So put the domain is all real numbers. The range is 0 to infinity. How is this graph right here going to change my range? 2 to infinity. And so what am I going to do to every single point here? Up 2. And you're graphing this with one of your... And you even need to shift the asymptote up 2, please. Same graph. That's why we have colored pencils. We're going to be doing 3 examples on each of these graphs. So 4 graphs total. Do I have any questions about what I did to graph that function? So tomorrow on your quiz, I suggest you graph the parent function and then graph the transformation if there is one. B. Is y equals 3 to the x plus 2. Well, didn't I just make that the last problem? This is different. How is this different? The plus 2 is the exponent, so what does that mean? Good question. Right? It's going to do what? Left 2. It is going to shift left 2. What's that going to do to my range? Nothing. So what's my range going to be? 0 to infinity. It's not going to do anything to my range. Can y'all see that green? Is that okay? Yeah. Okay. So again, we're going from our original one, my pencil one, and go left 2 from the pencil. And don't forget your arrows. So many of y'all forget that top arrow because you end at the bottom. So tomorrow when you're turning in your quiz, you're making sure you have equal signs everywhere. You're making sure you have an asymptote and arrows before you hand me that quiz. So tomorrow for your quiz, you're making sure you have equal signs, your asymptote, an asymptote drawn on the graph, and arrows on your graph. Like what we did the last couple days. When we're simplifying. Yeah. Not this. All right, you ready for the last one? For this page? ABC is y equals negative 3 to the x. What is negative 3 to the x going to do? It is going to reflect over the what? X-axis. It is going to reflect over the x-axis. Is that going to change my range? Yeah, to what? If I'm reflecting over the x-axis, it'll be negative infinity to 0. So just reflect your graph over the x-axis. Is it going to change my asymptote? Yes. However, it'll only have one graph. 22 minutes. So we're going to trade and grade. We're going to go over any questions you have on the homework. And your homework's going to have graphing on it. There's 3 problems from the bookwork that are graphing. And then we are going to take your quiz. And the quiz is individual. All right. Not open. Yeah, you can open up. If you open up, I'm going to glue this onto the page. So I'm going to put my next one right here. You can put it right next to it. If you don't plan on gluing it, you can put it right here. It's up to you. So wherever your heart desires. But I'm going to fold it again the other way like a book. And we are going to do the same thing, but now we are going to do a decay. No, so they're both, yeah. Again, it doesn't matter where you put it. I just want to be able to glue down, so that's why I'm doing it right there. And then draw your X and Y axis again, please. I don't know if I went far down on that one. What do we know about this function? It's decay. Because A is between 0 and 1. What's my domain going to be? All real numbers. And what's my range going to be? 0 to infinity. So just because it's decay, again, your range is still 0 to infinity. And I am again going to make a table. Please graph this function. Don't forget to draw your asymptote. Do I have any questions about how I graphed this, what I did? You are going to do the next 3 on your own. I'm what? Oh, y'all act like this is super hard. 100%. At least you're owning it. Focus. Alright, I'm going to give y'all about 1 song, 3 minutes to do these 3 graphs. Tell me about them in the bottom and then graph them. What are you?
Well, I think that's the calculator.
What are you?
What's the cow? What's the father? These are ones
They are. It's either leche or the frijol. It's either beans or.
Those are
No. Those are pastelitos.
No, I'll do that Friday. Yeah, I'll use that.
Are they not? Am I tripping? Oh my god, I thought I saw Bro, who works on these little like keep of them? Because she has 70 something.
Oh my gosh, I totally forgot how much of that. What is that? I'm judging. Oh, it's pretty.
No, who are they? I was looking at them. I don't know any of their things. I know this one guy.
My bad. I don't know. I'm not doing my fashion.
Yeah.
None of them are fashion. What should I do?
That last one's a little tough, huh?
Maestro.
Make a table if you don't know what to do.
Porque estaba pensando en esa Yeah. But she said it as a joke. Maybe I don't think she was joking.
Oh, even more. Wait, how did why is that so I'm gonna just, I saw it. That sounds good. Wait, why is it out here? Why was that 0 sound now? Wait, what did I do now? Am I tripping?
What does D do? It is a vertical stretch times 2. How does that change the range? How does it change the range? It doesn't. Because I know it's vertical, but because it's just stretching, it does nothing. So you are going to multiply all your y's by 2. 3, 1, 2, 3, 4. No, by 6. This one I cannot graph 18, so I'm not going to worry about it. What is this? This is D. E. What does E do here? This negative with the X. Say that again. It reflects it over the y-axis. What is that going to end up doing to my function? It's going to make it a growth. It's going to change it to increasing, and make it a growth. How is that going to change the range? It won't. So I'm just going to take each point and reflect it over the y-axis. My asymptote's not changing. Ooh. I probably count off points on that one. That was kind of gross. Alright, hey guys, hold on. Last one. This last one, in my opinion, is the most difficult. Do I think you're going to see something like this on the quiz or test?
100%.
I don't know. Would I? What is this going to do? We don't know. What does that 1/2 out front of the x do? It is going to be a horizontal. And actually, do y'all know how, look up real quick. Do y'all know how over here, whenever it's with the exponent, it's +2, but you do the opposite and go left? The same thing happens whenever you have a number out front. I get that it's 1/2. Your brain tells you that means to what? Compress. But it's actually stretch. This is a horizontal stretch times 2. And I want to prove that to you and show you by doing a table. And I'm only going to do the even numbers because it's 1/2 and I don't want to deal with roots. Are y'all okay with that?
Yep.
Okay. So if I were to plug in -4 right here, what's -4 times 1/2? And what's 1/3 to the -2? 1/3 to the -2. 9. So -1, 2, 3, 4 goes with 9. Okay? Right here at -2, if I were to plug in -2 right here, what's -2 times 1/2? And what's 1/3 to the -1? 3. So at -2, I'm going to go to 3. To the 0 power is still going to be 1. And 2. 1/2 times 2 is 1/2 times 2 is, and 1/3 to the first power is 1/3. So what happened here? This stretched horizontally because it took each point and it multiplied its x by 2. So this right here was at -1,3. Now it's at -2,3. This was at -2,9. Now it's at -4,9. It stretches it like this by multiplying the x by 2. I know that's weird. Again, am I going to expect you to be able to do that? Not necessarily. Oh, and what happened to the range? Nothing. I probably should have done this before, but I'm going to do it real quick. Can y'all go back to that half sheet? Or I guess you could write it on either side. I'm going to write it on the half sheet. Can y'all write that down? This is what your transformations look like. Again, what happens if I get a negative out front? It reflects across what? The x-axis. What does this plus d do? A vertical shift. And what does this c do? Or a horizontal shift. And last but not least, what would a negative in front of the exponent do? Reflect over the y-axis. So that's basically all the things we just did.
So we're done.
We are done. You have homework tonight. I'm going to post it again so you can write it. Hopefully you already started on worksheet 2. I don't know. I think they're 4 points each, I think. Maybe 5. But you're going to want to practice that for your quiz.
How many questions on the quiz?
10.
Oh.
22 minutes.
Just give the whole class.
No, because you need to trade and grade, and you also want me to go over some questions beforehand.
Then 12 minutes, I have a question.
Yeah.